I'm a PhD student from Indian Institute of Technology, Tirupati. So today we are going to look at two interesting aspects. Mostly to we are going to do is all the coding aspect this time. First is the confusion matrix for multi-class classification. We will see one example for that, and then we will see classifiers, multi-type of classifier for an NLP task. So we will do a lot of coding here. So let me start sharing the screen. Loading. Okay, I think it's coming up. Let me share this Google Colab notebook. Okay, so let me just give a brief of what we're going to do. We are going to do code for two problems. One is for confusion matrix for multi-class classification, where we will build iris data set and we will understand how to read the confusion matrix if I get a 3x3 confusion matrix, something like that. Similarly, we will go and look at the multi-level classification using NLP. So I will tell you what is difference between multi-level and multi-class classification. Then we will do a lot of tests, something called as common pre-processing test type, natural language processing task, and we will see lot of classifiers. So we will do a lot of classifier on the data set to get up particular data. So that's the overview. You can browse through the Colab notebook that link that I have shared with you. So let's start with the session. So the part one is confusion matrix for multi-class classification. Now this, so here our main purpose to understand how we can understand the if we get a multi-class classification like 3x3 in this case, how to read it. Okay, so first of all that we will build a classifier and followed that we will do that. So first the dataset is something, it's a very famous dataset called iris dataset. Now the iris dataset consists of the values related to three flowers that you can see on the screen right now. One is iris setosa, iris versicolor and iris virginica. So in this, for all these three flowers, we have four features. That is, there will be a petal length, and the petal width, and there's something called a sepal length and sepal width. So we have a data set for this, and I have uploaded that data set directly into the iris. Sorry, in this Google Colab. I will just share that with you as well before starting. So let me share. Okay. Okay, so what we are going to do is we will have the data set, we will see how the data set will look like, and then based on that we will build a classifier, multi-class classifier. So the classifier will be given, I have four features value, that is petal length, petal width, uh, sepal length and sepal width. I need to classify that which whether the flower comes belongs to which of these three categories, which of these three flowers. Okay, so um I imported few libraries like pandas.pd, numpy.mp, seaborn, and matplotlib. These are common standard ones. If we have to add some new libraries, I will tell you in the meantime. Now the first is I have to import the data set to data frame. So I will just let me quickly write it down. So I will take a df as ID, and I will use pandas dot read csv, and I will take iris dot csv. So once I have this, I'm reading the data set and I'm storing in a data frame variable called df. Then to see that what is the data set look like, I'll just do df dot head. I will get it the sepal length, sepal width, petal length, petal width, and species. So for different, so it all are float variables. Let me increase the font size as well. Okay. So I will have mostly different type of 4 type of features, and which species are they are telling like that. Now, to know the data type of the variable, you just have to write df dot d types. If you do this, since we have 5 columns here, so it will tell that sepal length, uh, sepal width, petal length, and petal width, they are all a float variable. And species we have of object. Object is here in this case because it can't store string, so it will store it as an object. So it has all the other different types of things as well. So let me show you that for each species how much amount of data we have in the data set. So if we have the species as output class, so this species will be a dependent variable, and these 4 features, sepal and petal related features, will be our independent variable. So since species will be output class, so we are just counting it value. So we will quickly do that. So we let df species dot value count. So once we do this, so we have with respect to Certosa, we have 50 data set, 50 rows. Versicolor, we have 50 rows. Virginica, we have 50 rows. So in total, we have 150 data points with respect to iris data set. Now, now once we know this little bit background of that how the data set is look like, so we just need to separate the independent variable, dependent variable. Dependent variable, since it's species, so we'll keep it in different variable, and independent we will keep in different variable. So let's say independent variable as x. So I will just drop this species one, df dot drop species, and axis is 1. So axis 1 means we are removing a column here. Now once we have this, y will be a dependent variable, so we'll just use df dot species. Now what I will do is I just print the different values and with respect to the independent and dependent variable. So I will show you what is the independent variable look like, and what is the shape of that, like how much data values that we are having. Then similarly for dependent variable as well. Head.
Sir, what is mean by axis?
Axis 1 is equal to column, axis 0 is equal to row. So when we are saying,
Thank you, sir. Thank you.
okay, yeah, so I'm just printing it out so to see that how it's looking like. Okay, so our independent variable values will look like this. It has a shape of 150 into 4, that is 150 rows with 4 columns. This is for the head of independent variable, and it has 150 values with 1 column. Now once we have this independent and dependent variable segregated, what we'll do is we will split that into train and test thing. So from sklearn, import train test split. Let me just look at the correct version of this. So I will do train test split sklearn. Let me look at the model selection. Model selection, and okay, so now we'll store this train, x test, y train, y test, so train test split will be r x y, test size random state. Okay, test size I will keep 0.25, and random is equal to, I'll just give 0 value. There's nothing much we can do here. So once we have this, let's okay, so it's, what is the random state? Okay, so once we do this, if you want, we can see the shape and shape of the train and test data. So we will just do x train dot shape. Just let me copy it. X test y. So we divided our training and test data into 75 into 25. So test data will be 25. So out of 150, 38 rows we will giving for testing, and 112 rows we will be giving for training. Now once we have this, we will use support vector classifier. I will tell you about the different type of classifiers in this session itself. So let me import few things. So from sklearn.svm support, sorry, import svc, and I'm also importing the matrix one for the confusion matrix. Import confusion matrix. Now we just have to create a classifier using this. So we already have train and test data. So what we can do is clf svc kernel is equal to linear. The kind of functionalities function it will use the support vector machine to fit a model. It has a lot of options. So for that, if to know more option, you can go to the sklearn website to see what different kind of kernels are there for them. X train, Y train is there, and we will just predict for sake right now X train. Unknown label type is continuous. Okay. SVT continual T train. Okay, so there's some issues there. Let me see what's the issue is. Just a minute, I'm just checking out. Okay. Okay, I need to convert that to zeros and one. Okay, fine, fine. Okay, just give me a minute. I will just see that how to solve this. Just a minute, I'm checking out what to do here. Ideally should work. Where it is wrong, where it is wrong. Pieces. As we see, kernel linear, fit train, extrain. Yeah, it should work. It should work. Should work. Okay. Okay, I'm just checking my old notebook where I've done this, and I have seen no problem as far as now. it is working perfectly fine here. I have no idea why this is. Let me run from start here. Okay, I will just show you my old notebook here in this case. I'm so sorry, I'm not able to figure out what's is happening because same code is I'm doing. So I did should run. Let me share the screen again. Okay, I will share the screen just to show you that what is happening, and then based on that I will write the rest of the code because ideally it should be working it out. Okay, so we have done that. We have import the support vector classifier from which we are using sklearn matrix to import confusion. Until here we wrote, and after this, so we are creating classifier. So we are using svc as a command and using kernel as linear and fit x train y train, and we are trying to predict the x train to just check that for each x train what kind of prediction it is happening. Okay, now this is how it should get. So what I will do, and then in the notebook that I am doing, I will write it down, and if because for this part I am not able to run that thing because certain error, I will show you the output directly here. Okay, so once we create a svc kernel linear kernel here, which ideally is same as this byte in x train dot fit, what we have to do is we have to use the model that we are getting, and we have to predict the value for the test cases. So if I will write ypred, and I will do df dot predict and x test. Okay, so sorry, clf dot predict. So my classifier would be made here. So based on that, I will just do classifier, and I will do the x test. Now once I do the x test here, now what is it will it will not show any output, and then we can create a confusion matrix, which we can do using cm equal to confusion matrix. So what we'll do, we will just predict, we will compare the y prediction value with its test value or the original test value. So we will just check observed value versus predicted value. So once we get that, we'll get we are storing the confusion matrix cm. To make it more visible, I will just do cm. I will just creating a data frame where we can store it much more properly, because it's a 3x3 matrix. So cm.df pd.data frame cm index. So I will just do setosa. I'm just defining the data frame such that in the confusion matrix output you can see it clearly. Var c color and Virginia. This is for index, and same we have to do for columns as well. So if I do this, Just copy the same thing. Okay, so once I get it, I will get a cm dot data frame, a different type of data frame. I just have to plot a figure for this. I will show you that in a few minutes. So just let me complete the code here. So 5.4, I will just do heat map from C1 library to show the confusion matrix. And then I'll just give the title of that graph. So I'll just do confusion matrix and plt.y label. Actual values, plt.x label, predicted values, and plt.show. If I do this. Now let me show you the code that I have written already there, and I will show you that how they give output. I'm not able to run this because of I have to check that what's the actual problem here with the fit function. So I will just show you here. So the same thing we have done. We predicted the x test value and showed in the y prediction variable. Then we created a confusion matrix called CM. Then we create a data frame which we can telling the index and column name. We are just defining it properly, and we are plotting the confusion matrix. So this confusion matrix will look like something like this. Okay, now this is a 3x3 confusion matrix which is different from the 2x2 matrix that you have seen already, which contains true positive, false negative, false positive, and true negatives. Okay, so how to read this thing? So let's understand it with one example. So before that, consider that this heat map is you define the cell name numbers like 16 as cell number 1, 0 in the same row as cell number 2, 0 at same row number 1 is cell number 3, row number 2, 0 is cell number 4, then cell number 5, cell number 6, cell number 7, 8, 9. This is for our understanding. We will keep this as 1 to 9. Okay, row wise we are doing 1, 2, 3, 4, 5, 6, 7, 8, 9. Now once we have this, we usually we need only we need 4 values. It is true positive, true negative, false positive, and false negative. So how to read in this places? For example, we take for setosa. Now the true positive will be the actual value and the predictive value should be same. Okay, so the actual value and predicted value should be same. That means this setosa, that is actual value, and this predicted value is setosa. So this cell number 1 is the true positive here. So we will say cell number 1 is equal to 16 shows true positive values. Similarly, now false negative is the sum of values corresponding rows except the true positive values. So that means within the same row of setosa from actual values, we will look out for the cell numbers which are except the true positive value. So that means in this case cell number 2 and cell number 3, which we are focus of interest for false negative. Okay, so false negative in this case is cell number 2 and cell number 3, which is 0 plus 0 equal to 0. Okay, now false positive. Now false positive will be, we have to see the column wise here. Now, false positive is sum of all values corresponding column except the true positive value. So in this case we will focus only on this column number 1, which in this except 16 we will look at cell number 4 and cell number 7. So that is in this case 0 and 0. So we will say cell number 4 and cell number 7 equal to 0 plus 0, 0. So we have false positive is 0 value. Now True negative will be sum of all columns and rows except the values of the class that are calculating the values for. That means we have to exclude, for example, for setosa, we have to exclude the row and the column wherever it is intersecting. So that means the column number 1 and column number row number 1 we have to exclude, and whatever remaining will be, that is in this case 17, 1, 0, 11, we have to take that as a true negative. So in this case, cell number 5, cell number 6, 8 and 9. So with the values of 17 plus 1, 0 plus 9 will be 29. So if we just read like this, so your for setos, it will be true positive will be 16, false negative will be 0, false positive is equal to 0, true positive is equal to 29. Let me take another example here. Now we will take for versicolor here. Okay, now versicolor is the middle one. So in actual values, versicolor is the second row, and in predictor value, the versicolor is second column in this case. So by definition, the actual and true positive will be the actual value, and predictor value should be same. Okay, so in this actual and predictor value in this case is in the mid, it's a cell number 5, which is 17. So we will take that 17 and we'll say that as a true positive value. Cell number 5 is equal to 17 is a true positive value. Now the sum of values of corresponding rows except the TP value, true positive value. So we will look at the row. In this case, this row, row number 2, we will look at these values and we will check for false negative. So except 17, we have to look for other cells. So in this case, cell number 4 and cell number 6, that is 0 plus 1 equal to 1. So if we have cell number 4 and cell number 6, 0 plus 1 equal to 1 will be a false negative. Now for false positive, you have to look at the corresponding column, okay, for the true positive value. So in the true positive value is in this in the middle, so we have to look at the column number 2. So in this, the cell number 2 and cell number 8 we have to include, not cell number 5, because it's a true positive, we don't have to touch that. So in this case, cell number 2 and cell number 8 is equal to 0 plus 0 equal to 0. Okay, now the fourth last is true negative value. That means we have to select all the columns and row except the values of the class that calculating the values for. That means since we are focusing on versicolor, so we will exclude row number 2 and column number 2. We will look at the remaining values. In this case, 16, all the 4 corners, that is 16, 0, 0 and 11. Okay, so we will look only on this, and so if we calculate 16 plus 11 is 27. So that's how we will get the 27 value. So if you want to build a confusion matrix for this, so it will look like something like this: TP is equal to 17, Fn is equal, false negative is equal to 1, false positive is 0, and true negative is equal to 27. Okay, now you can do for Virginia as well, same concept. You look out for the 2 examples and the definitions here, you can find it out and you can make the confusion matrix something like this. Okay, okay, so now I would have done that there, but I will just post all this value what I have done at the end of the session, all this value that I have calculated in the notebook that I am going to share with you. Okay, with solving the problem of the classifier, that why I'm not able to build a classifier. Okay, now to find the accuracy of the model, you have from this true positive, false negative, false positive, true negative, you can find precision recall F-score value. For that, the formulas are already given. Similar to identify the accuracy score, you have to import the accuracy score function, and then in that you have to give 2 parameters. First parameter will be the prediction value, and the second variable will be the actual values. So y-test is actual value and y-pred is the prediction value. So we will do that, and if you print the accuracy score, in this case I got 97.7 or 0.98, something like that. You can do that. Okay, and classification report. The classification report contains precision, recall, F1 score, support, accuracy, micro average, weighted average, and all that. So for that we can import classification report, and we are taking target names. This target name will help us to segregate for each class of this Serosa, Versicolor and Virginia, we will calculating the precision recall F1 score value. Okay, so if you print classification report y test will be the actual value, ypred is the predicted value, and the target names. Therefore, the target name is the class's name. So we will get our value something like this. I will discuss about macro average, weighted average, or macro F1 score, weighted F1 score in some time when we go for the second part of the session. Okay, so now this is how it should be. I'm just, let me copy this code here. I'm very sorry that I have to check that where this function is not working here. This fit function should work, but somehow some problem of label continuous, I need to check where it's coming from. Maybe somewhere I did some misdealing with the data, so I have to check, but it take me some time. So right now what I will do is I will just post the remaining code here. So I have done this, so I will just remaining code, and then I will jump to the second part of the session, that is because it may take a little bit more time there. So I will focus on that, and let me while sharing I will share the proper fix code, and let me see if you have any doubts now. Based on that, then we'll go for multi-level text classification, and we have to discuss a lot of things here, so we will jump here as well. Okay, let me see. Okay, so if you do little bit practice, you may able to understand how to calculate the confusion matrix. It's not for 3x3, for any other confusion matrix also, be it 4x4 or 5x5. If you do employ the same strategy, you will able to calculate the precision recall or the confusion matrix for each class. Okay, that being said, let's go to the second part of the session, which might interest you here. That is a multi-label text classification. This is little out of the syllabus. This is something the course is it's not included in the course, but the classifiers are included in the course. So I'm just giving a use case of that. Okay, now most of the time you have seen from other TS or myself or in the class that we have mostly do the binary classification or max to max, 2 or 3 or 4 classifications in term multi-class classification like that. Now we will see for multi-label classification. So multi-label classification in a just it is like, so if I have an image, in this case I have a digit, so that digit can belongs to 0 to 9, any of this 9. Okay, so it can belongs to 10, sorry, multi-class, it can belong to one of the 10 classes 0 to 9, so it will assign only one class to that. So that is we call as multi-class classification, that you have multi-classes, that is 0 to 9, 0 to 9, that is 10 classes are there, but for a given input you're giving only one single output, that is one of those 10 classes, right? But multi-label classes was what happen is, especially in image regression or text classification, that an image have multiple objects, and if your model is able to identify that multiple objects, so you can label classify that image into multiple classes. So if a image contains cat, tree and car, and your labels also contain those things, so it will label that particular input with these 3 classes, that is class, say cat, tree and car. Similarly, if I have a text file, a document, and I have some sentiment analysis, I'm doing emotional analysis, I'm doing that, in which I'm trying to understand that what is the person who wrote that particular document, what the person might feel like. So based on that, based on analysis of the content, I might assign 2-3 labels, that the document might contain joy or very happy. So as I can have 2-3 labels. Label means I can assign 2-3 class for the particular input, but in multi-class I can assign only one class with respect to this. That's the main difference between this multi-label and multi-class, and we are focusing on multi-class classification. That is, we will take a Reuters data set in which we will have approx 90 classes, and we have approx 8,000 training or approx 10,000 samples. So it will divide for each document. It will analyze each document and try to give multiple labels from the 90 classes that they are having. Okay, so we will do multi-class classification, multi-label classification using NLP in this case. I will tell you a little bit about natural language processing, that how since we are dealing with text data right now, till now you have mostly deal with numerical data. Now we will see text data. So how to pre-process them and all that, we will see the step by step. And I will, rather than telling each and in depth about each and every classifier, I will just show you how to use multiple classifier for the same data, and how you can use it and how to interpret the results. So that's the overview justification of multi-label text classification. Okay, now that being said, I will be taking a rota dataset that, as I said earlier, so it has 90 classes and approx 10,000 samples. So I will taking that from NLTK library. NLTK is a very famous natural language processing library. So I am taking from that. Then I have an NLTK library itself, and then I'm downloading NLTK download. I will download the routers dataset. This WordNet dataset is used for data pre-processing, so I'm downloading that as well. Pandas has PD for data frame. There's something called as lemmatization and stemming. I will tell you it comes a part of natural language pre-processing. I will tell you more on that. Then we have put NumPy, and we have taken some typical train test split to divide the data into training and testing data. PyPlotlib is uh, for visualization. Same yellow bricks also is for visualization. We might skip visualization now, but maybe in the end, while if we have time, or if or later while uploading the thing, I will show how yellow bricks works. Import warnings is basically if I have some warnings with respect to any files, it will just ignore that, so it will not show us. And there's something called stop words. This come also a part of pre-processing. So I'm downloading the punct and stop words files from which I can use. I'm going to use that during the data pre-processing part. Okay, now that being said, what I will do is I will now I have wrote a data set. It's a very big data set, and maybe we can't load it. So what I will do is I will try to divide the data set into train documents and test documents. So let me do that. So I will divide the train data set into train category, train documents, and test train categories. So zip is not the actual that kind of zip folder that you have seen. This is a it's a library function which help us to get the data directly uh, from the row wise data from the data set that we are having. So what I am doing is, since we have the data set and it has been defined properly at training and testing, so we just putting those things into train documents and train categories. Okay, so routers dot categories I, and we just let me write this thing. So it works in tuple, it will work fast for us. So after this I will write a short loop here for I in n routers file IDs. In the file IDs I have to check if I dot start with training. Okay, so what I am doing this, I am taking the raw data and I am taking the categories I. In that I will check the each raw data and category, and I will check that in that row I will check the first I will check the file IDs. In that file IDs I will check that whether the file IDs has the word training in that or not. If it has a training, that means we will put that in a training category. Similarly, if I have to make a test document here, so I will just change few contents here, test document and test categories. The remaining will be same. The only thing we have to check is test. Okay, so again this function is basically look at the router's data set. If you look at the raw means the content which is presented in the document, it will check the categories and it will select those categories. It will check the those categories and content from the file IDs where uh, from where the row contains training, where the row starts the training variable. Similarly for test, it will come from, if you want to find for test data, you have to check for the test variable word in that. Okay, I think someone has. Uh, let me see. Okay, yellow brick right now, don't focus on that. That's a visualization library. I will tell you later how to do that. We have to install certain libraries before that. So I will describe that thing. Uh, that's not right now is important for, but I will show you that why it is used later. Okay, so once we get 4 values, that is we have train documents from routers.raw and train categories from routers.category. Same for test document test categories. I'm just going to print the number of documents and test documents and train documents I'm having. So I will just do number of training documents. I'll just use len function here. Documents. Similarly, I have to do for test train documents is not defined. Oh, I haven't run this. Okay, for that I have to run above also. Okay, let me start with, it will download the routers and then it should run this. Sorry, come again. I haven't run.
File name is test.
Okay, yeah. I have to change few things. Yeah. So we have approx the same number of that it is showing. It's just that I just directly taken out from routers.raw value. Okay, because we can't directly get that value, so we have to do certain uh, analysis on certain script written on that so that we can get that in a proper variable. Similarly for train and test categories, if you want to do, just let me copy here. So I will just do train category and test categories, and I will just change this. Okay, it's the same number of categories, that rows that we are having, we will have that. Okay, so before going and telling about what we are going to do next, a little concept that I need to cover. There's something called as multi-level binarizer. So what it tells is, in multi-level classification, you have multiple labels, right? And if you have multiple labels, how the system has to understand that in a particular way that this belongs to a particular labels can be on multiple numbers. So if I have 90 classes, they might be only in 2 classes for a document or 10 classes for a document. So the number of variables might be changing. So what multi-label binarizer do is it creates a binary matrix representation, which helps the system or the model to understand that okay, for a particular document these categories are there. So for example, in this example I'm going to show you a sample example here. So I have certain labels for a certain thing. So in that, one label has cat and dog, one label has only dog, one label has bird, cat and dog. Now if I use multi-label binarizer and put a fit function on that, I'll get a binary labels. Now the binary labels will look something like this. If you the below the array 1 1 0 0 1 0 1 1 1. So what it is doing is, for a particular, suppose this particular document is there, so if it is giving label of cat and dog, so it is defining it as, now it has 3 categories, that is cat, dog and bird. So that's why it has 3 cross 3 three columns. So one might be cat, second might be dog, and third might be bird. So for first document we have only since for the first document we have cat and dog as label, so it is giving 1 and 1, and for bird it is giving 0. And now in second document only dog as a label is there, so second is a dog, so it is giving cat as 0 and bird as 0. Similarly in third document it is giving bird, cat, dog as 1 1 1. So it is so labels, so it is giving 1 1 1 label. Similarly, what now this will help the model to understand that instead of separately trying to understand what the label means, it will create the 90 cross 90 matrix in the particular problem, and it will create something like this binary matrix, where it will just present that for a class, if 1 is there, that means that 1 represent that for that document that label is given, 0 means that label is not given. Okay, so that's what it will do. So we need this matrix for the model to understand that which label for which document which label has been assigned. Okay, now to do that, I will, let me write the code here. So from sklearn preprocessing, this needs to done only in multi-label scenario. For single classification, if you have multi-class classification, you might not need to do this, because you only have to assign only one class to them, not multiple classes. So we take multi-label classifier, and we might write the same code that we had written earlier. So binarizer, I will just call this function, keep that MLB as an object, and for train labels I will create a matrix. So I will say MLB dot fit dot transform. So fit dot transform is, it will the fit function on any kind of models or any other functionalities you might find. It use certain kind of equations to convert that data into a certain different form. So in this case, when we're saying fit, it was converting that into a it is try to understand the data, based on that it transforming that data into the matrix form that you can see on the screen right now in the black highlighted region, right? So the fit function in this case, it do like this. In classifiers, if you see a fit function, that means it is trying to understand the data and try to create a certain, like, if to tell you from the perspective of linear regression, try to fit a line. So similarly, for different classifier, different kind of strategies will be there for different equations. That same thing fit functions do, and then it try to transform the data also for the later processing part. Now we have done for train labels. Now let's do for test categories. Now for test categories, we just need to do transform, because it has already learned the different kind of patterns from the train data. So we just have to do transform function directly. So if we do transform ml.transform, it will directly convert this to this kind of array, because fit.transform function of the MLB model is only learned from the training categories. Okay, now that being said, how much time is there? Okay, let me done the do with the data frame processing part, then we'll take a small break, then we'll come back to pre-processing step. Okay, now I have to create a data frame after for applying the transformation. So let me do train data, and content will be my train documents, and labels. So I have only one have contents and one has labels, so I will just using that, and has train labels. So train labels, this will be a matrix, it will be a binary matrix, the one we have seen as an example above. So test data will be same. So we have right now creating our dictionary here, then from that dictionary we are just convert that to a data frame. So yeah, I have to do test labels, and here test documents. Now once we got this dictionary, now we will do the data frame. Now this data frame we will use for pre-processing and other stuff, basically uh, to use this in the classifier. So we have data pd.data frame, and then I will take train data, and I will take columns equal to content labels. So I'm just defining the data frame format and the from which data you have to take. Similarly, train df, it will be like pd dot data frame test data columns, just keep the same format as it is here. Okay, now once we done this, let me run this code as well. So if you just want to see that how the train data should look like, okay, some problem is there. Okay, just label. What's the problem here? Labels per column must be one dimensional. Okay, now we have train data, train label. Okay, once we have this, I will check that what is this thing, and once we have, okay, now once we have this, we just, if we do the train data or train df dot head, you will get the different kind of output. Now the output will be here, something look like this. I'll just show you here. Yeah, the something good, look like this. So we have a content, and for that we have labels. So this top 5, this only one label, but if you go above, we'll find multiple labels. Okay, that being said, this is 7, so we will take maybe by 7:10 will come. So what we will do now after this is we will look at the pre-processing step. Once we get the pre-processing step correct, then we will go for the classifier. So we have multiple classifiers in below. So from KNN classifiers, decision tree classifiers and all that. We'll discuss in briefly what is there, and then we will try to quickly calculate the classification scores for different kind of for different classifiers, and compare that which one is better for this particular data set. Okay, now we will come at 7:10. Okay, so we are taking the break till 7:10 and then we'll come back. Okay, let me see. Okay, so what is the problem here? Okay, we'll start with this. So when we say natural language processing task, natural language deals with all the textual data, be it any language, but most commonly we show for the language English. But at the same time, there are libraries are there for in which you can use your regional language or popular regional languages or any other different kind of foreign languages. For that, they have the libraries. Now, to since we have a data in terms of natural text, in this case let's say English, we have to do some certain pre-processing step for that. Now, why pre-processing step? It's basically to convert data in a such a way such that the machine could able to understand that what that word means in the sentence. Okay, so it converts the all the text data into a certain numbers, and it will not just convert just like that. It will try to analyze that what is the role of that word into that particular sentence. Okay, so that's why we need pre-processing for those each words and all that. So there are 7 stages are there, that is tokenization, lower casing, stopper removal, stemming, lemmatization, normalization, feature extraction. In this, some you may use all or some may use some of them. So let me try to tell you what make understand that what it word means. So first is, for example, let's take an example. Jana went back to university. Now usually when you are uh, taking this as a sentence or any document, so all document consist of list of sentences, right? So we are taking sentence, and first task is we have to make it all them as lowercase or uppercase. We usually do lower cases in for better understanding. So when we say normalization, it's basically removing all the numbers, punctuations if we have, or special characters like comma, uh, or hash, or different kind of things. So you try to remove that and just keep only the words, that too in the lower case. Now from that, the important part, this is important, this part which cannot be skipped, is tokenization. Now tokenization is the most important step here. In that tokenization, you divide that sentence and make tokens. So each word will become a token. So that means Jana has become one token, went become another token, back become another token. Similarly, university become another token. So since we have 5 words in that sentence, so we have 5 tokens. This is something we cannot skip. You may skip normalize, but you cannot skip tokenization. Now, another thing is we do remove stop words. Now, why stop words are there? Because these words are basically very common words, or they don't give any much value while to make the machine understandable. So, for example, a or the, or in this case to or was, right? So there are certain words are there. I will show you that what words are there. Just let me show you the words. So if we, so the stop words, there's a list of stop words agreed by the people. So we can get it from NLTK. So I'm just showing the stop words related to the English. So like I, me, my, myself, we, ours, ourselves. So there are lot of stop words are there. So we are removing this because according to us, we have to minimize the data computation. So in this case, we will remove the such words which might not add value. And we are when we are reading, we don't focus on two, we mostly focus on Jana and university, right? So machine also should able to understand that back into might not have much value, so you should focus on Jana, university, and went in this case. Okay, now this is also important. You might skip this, but ideally it's good because it will reduce your token size, because here in one sentence itself you have 5 tokens. So consider you have a document, it might have 300, 400, 500 words, or maybe a list of words and like that. So it will be very very big computer process. So if you do remove stop words, most of your tokens will be went away just like that, because it consists of lot of a, the, and other kind of words. Okay, now another thing is, uh, can you please mute yourself? Yeah, Pushpendra, I guess. Can you please mute? Okay. Uh, Now the fourth step is stemming and lemmatization. Now this is another important one. So what we are doing is when we want um the machine to understand its basic form of words, not the different kind of words. So a base form of word will be like for went, it was sorry for went the base word is go, right? For university the base word is universe. So for stemming, this base word is stem, right? So what it is doing is it's reducing the words into their base form. So it just either it removes the suffix. For stemming includes removing the suffix. So like uh, if a word is plural, it will make it singular. Okay. Now lemmatize, what will do? It will bring that to base form. So when to go. Okay. So now why this help is reduce the dimensionality of data. So I might have multiple meanings of go and went in multiple cases. So if we go back to the base word, we can cluster them together and it will help the machine to better understand that okay, when we're talking went, it actually means go. So if I have some other document where the word go is present, so I will combine Jenna went back to university with that document. So that's why stemming and lemmatization is there. Now the sixth part is feature extraction. Here we use TF ideas. I will tell you more about that in the few minutes. So let me write this three or four common pre-processing words. So steps. So what I will do is I will take WordNet Lemmatizer. So WordNet is a data set from there where it contains base words for almost all the words available in the dictionary. So we are just calling that function keeping in word not lematizer. So then stemmer, this will help for stemming process. That means it will reduce the suffixes from the word that is like plural to singular. If you have continuous pronouns, continuous past continuous and all those stuff, so you will just convert that word to the basic form of word. And then we have stop words. So set of, so I'm just giving set stop words in a data structure called set English. Now let's, if these things are defined, let me define this function tokenizing the data basically. So I will tokenize and I'm just giving this word as stop words, and I will provide something called text here. We will see what text will come here. So first thing is I am removing all the next line component. So I will just do text dot replace. Replace is a inbuilt Python function. So it will just replace any slash n, that is the next line character, with a space. Okay, it will check for that and it will remove that. Now the first part I have to do is split the string into words. So basically I will do the tokenization process here. To do that, now I will store that in tokens. So I will use NLTK library tokenize dot word tokenize, and I am converting whatever the word will be there, I'm just converting to lower. So I'm combining two steps, the normalization and the tokens into one. So text dot lower. So it will, if anything which is written in caps, it will come down to that lowercase words. So I am doing tokenization, that too with respect to lowercase, converting them to lowercase. Now another normalization that I can do is that I will remove all the numerical or extra characters, special characters, and I will only keep alphabets. So if a word contain only alphabets, I will keep that, otherwise I will remove it. So for do that, I will just in tokens only I will do uh, for t for t in tokens. So every t token that I am taking, I'm just checking if t is alpha. If t is alpha, I'm keeping that token. Okay. Now the next pre-processing that I can do is put words in the base form. That is lemmatization. So for that, lemmatization and stemming, both I will do here. So to do that, I will use tokens, and I will, since I have devised wordnet lemmatizer, so I will write a loop wordnet lemmatizer dot lemmatize t, and for t in tokens. So for each t in tokens, I will just lemmatize that token, and I'll keep that in again keep that in tokens. So that is for lemmatization. And for stemming, stemmer dot stem t for t in tokens. Okay, now this is done, and the only last thing I have to do here is top words. So no, another normalization I can do is remove short words, because they might not be they are probably not useful. Okay, now what I will do is I will again check the tokens, and I will select only those t's in tokens if length of t is greater than 2. If that is there, if it's less than 2 or 2, I will not take it, because it ideally it would be have removed, but still from stop words, but there might be some chance that some words are there of 1 or 2 words characters, so we'll just remove that. And just we do stop words as well for t in tokens if t is if t is not in stop words. So we're just removing the stop words here. So the almost uh, all the pre-processing step we have done, and then we just combine them using join function, and I will store that value in tokens, sorry, in clean text, and I will just return clean text. Now if I have to call this function, so I will do one more layer I will die, that data cleaning, where I will just pass a data frame. So that data frame will be df dot copy. I'm just copying the data frame and keeping separate file, and I will just put data content, and then I will put data content dot apply. I'll just call this tokenize lemma stop words. So what is happening, I'm just whatever the data I'm going to get, I will make a copy of that, and I will just focus on content part, not the classes. So I will just only focus on content part of the data set, and I will use the tokenize lemma stop word function now, and then I will just do return data. Data will be a data frame in this case. Now to have to call it, I will just do clean train data. So it will be like data cleaning train df. Okay, and data clean test data, data cleaning test df. So what I'm doing is I'm just passing train df and test df, which is a data pandas data frame. I'm making a separate copy of that in data because I don't want to corrupt this df. So I'm just doing that. From that, I'm only going to pass the content value, not the category value or the labels. The labels that we are having, we are not going to pass that. Only passing the content, and in that content we are going to apply the text processing that we have discussed just now. So for each document, it will come back to a number of tokens at which it might look like this. Okay, so this function, and we get the output like this. So let me run this. So for each document it will do, for 10,000 documents point it will do that. So till the time it will doing, let's focus on the next part, which is called TF IDF vectorizer. This is the last part of the uh, NLP pre-processing type, that is feature extraction. That means you are transforming a text data into into a into a feature vector. That means numerical feature vector. So what does that means is, let me take that as an example. So what it will do, it works on something called as term frequency, document frequency. I'm not going deep, I'm just going to tell you on surface that what it will do is, if I have a function cat, if I have a sentence like I love my cat but the cat sat on my face, or I love my dog but the dog sat on my bed, if that kind of words are there, I will tokenize it, I will make it stem, I will do all the earlier pre-processing step. Then what I will do, for each word I will try to understand the importance of that word in that statement. So what is the importance of cat, what is the importance of bed, what is the importance of face, love, all these things, and then I will give a certain kind of numerical value for that. That numerical value will come from term frequency, document frequency. That is, term frequency is number of, if I am having a cat as a term, how many times that cat is occurring in a document. Okay, now document frequency is, if I have a cat as a term, and I have two documents. In this case, I have two sentences here. I love my cat one and love my dog. So in this case, how much that cat term is coming in both those documents. So that is something it is calculating. So based on that, it has some formula, and based on that formula, it calculate a numerical value for each and every word that you have in the sentence. Now, if you see that I has been removed, the might be there because they might not use the stop word here properly. But or if you remove all these things, this sounds that this my own, that all these things might remove, and only you might have cat, face, dog, or bed mostly in your things, and then it will try to give a probability of those things. Now, how it is help is, if I have a I love my cat but sat on my face, that as a vectorization. So for this statement, I will get a set of arrays, a array in which each value represent one word. So that bed will represent one word, represent one numerical value. So bed will represent 0, but represent 0.23, cat 0.464. That's how it will convert a textual statement into numerical value, numerical array, which we'll call as vector. Now this vector we will use for our classification, model training, or other purposes. This step cannot be avoided. This is one of the most important steps that we have to do. Okay, so to put TF-IDF vectorization, I will have to import sklearn library, uh, feature extraction dot text import TF-IDF vectorizer. Okay, and I'm also putting some sklearn dot import metrics. Okay, so I will create an object of TF-IDF vectorizer. So TF-IDF vectorizer, I will create an object of that, and what I will do is I will just vectorize the whole training and testing document that I am having. So vectorized train document, and I will use vectorizer dot fit underscore transform, and I will just pass the value of clean train data, that to content. I just need to convert TF-ID of vectors of the document, not the labels. So I'm doing for that. Similarly, uh, for test, just copy this. So for test document, clean test data, if I pass that, and I will focus on only on content. Okay, so it will take some time for that. Okay, oh, it is done. So that means right now what we have done is we have done the pre-processing of data, where for each document we have applied this process of normalization, tokenization, remove stoppers, stemming and lemmatization, and now we converted that each document. After converting those pre-processing, we convert that into step in the arrays of numbers. So like this, we have converted data arrays of numbers, and we have stored that in vectorized train and test document. Now, before applying for classification, what I have done is I have written a code basically to just directly to calculate the accuracy score, precision score, recall score, reference score. Say a lot of scores are there, so we're just using those scores and we are keeping them in a certain format. So whenever I will, we will run a classifier. After that, we just call this function with model name and test labels, the actual data and the predicted data, and we will try to calculate all these values. I'm not writing this again because it most of the things you concept wise you already know. What you need to know is mostly about macro averaging and micro averaging. You might have seen earlier that for a classification report you might get a lot of value apart from precision recall F1 score. Now the macro averaging is basically for each class it will try individual precision recall. So for example, the same way we have done earlier for confusion matrix, that if you have 3 by 3 confusion matrix, from that we made a 2 cross 2 confusion matrix for each 3 different classes for iris data set. Similarly, macro averaging will do for that. Now micro averaging, what it will do is it will just take the precision value of all the 3 classes. Like from example, if taking the example of iris dataset, it will take the precision value of all the 3 classes and it will divide directly by 3. That's why it is said globally across all the classes. So it is not going to separately calculate, it will just take the values directly for precision and it will directly divide by 3 to give that values for precision recall, F1 scores and all that. For to better understand it, you please refer this article. It's very clearly explain of what is the weighted average, what is micro averaging, macro averaging, and all that. Okay, so I will just tell you what I have done in this function. So from the sklearn matrix, we have imported accuracy score, precision score, recall score, reference score, confusion metric, Hamming loss. Now Hamming loss, you can just it's another matrix you don't have to do. If you want to learn about Hamming loss, you just do sklearn Hamming loss, you will get the data about that. Now we have a model performance dictionary where we will be storing the F1 score. So what we'll do at the end of the classifiers, we will basically see that which classifier perform better. At that point of time, we will take this model performance variable and we'll see that we'll compare those values. Now, so we have defined a function called metrics report, in which we'll provide a model name, which might be a string, which will be a string, test label, so like the y test that you usually do. So test labels will be have, and prediction labels that we are having by the classifier. We'll have this, from which we'll calculate the accuracy score, then we'll calculate the precision score based on that, and same test label prediction we will give, and the average we are defining here, micro, macro, macro for precision recall F1, and for micro also micro, micro, micro. Okay, and then we are printing for a particular model name, we are printing all the different metrics that we calculated to tell us that which one is to tell us the performance of that particular classifier. So that's what metric reports do. Okay, that's a function directly I defined rather than again writing it again and again. Now the main part is, so considering the time limit, I will just show you for few classifiers, and I have so we have some context is already given with images, so please look at also after the class is over. So let's talk about classifiers now. So classifier main task is, if you have input data, you have to classify that data into either one or two classes or multiple classes, like that, right? So KNN is one such classifier. So what it will do is, I have already have some already have some might be I have some classes already available. Okay, now class A, class B, just like this in this there. Okay, it is there in some hyperspace. We don't know it's in terms of number. So what KNN classifier do is, I will just give one input. So I need to know that that this question mark belong to which category, either the star or either triangle. To classify that, what I will do is, I will take some samples. So sample is, for example, if I take k equal to 3, that is k nearest neighbor. So from this point which I need to classify, I will try to find the 3 nearest neighbors of these things, and from this 3 nearest neighbor, I will try to identify that from which type of class it is more nearer to. So in this case, when k is equal to 3, it is showing that out of 3 points that I am 3 neighbors, 2 neighbors are triangle and 1 neighbor is star. So there's a high chance that I might classify them into a star category. The new input will be belongs to star cluster. Okay, but if you change the k, if you increase or decrease the k value, in this case, if I'm k is equal to 7, that means I'm trying to find for 7 nearest neighbor with respect to this new input point. Then I will find that I have 4 points, 4 stars and 3 triangles. Now based on this, I will find that, okay, I might need to classify this point into star category, star cluster. Okay, so it is something, this is not a perfect answer for any of this, but it's just that it used distance measure from to see that to classify itself into either either any of one of the classes. Now KNN is called as non-parametric algorithm, which it doesn't assume anything much about the underlying distribution. So what it will do is, right now we have already defined this cluster, right? So how it may start is, it may take any one such point and it will try to see that, okay, if this point is triangle, if my nearest point is triangle or not, the other triangle is not. That's how it's a sequential process where each one will look at each other neighbor, and based on the liking or certain properties, they will combine together to form one particular class. So in this case, triangle will be there, and in this case, stars will be there. That we are going to get it through the training data. Okay, and this k value needs to be identified properly. That's why we have KNN algorithm, which try to identify the best possible k value. So when a test data will come, it try to see that in which kind of classes that input needs to be put in. Okay, now to use KNN classifiers, we put sklearn.neighbors input k neighbor classifier. There's something called sklearn1 versus rest classifier. This is something I might discuss later, maybe another class. This together, it's a little different concept, so I will talk about that later also. So I will just write a code which mostly we're going to use for other classifier as well. So I will use rf classifier as a variable, and in this, that's an object of that will be the object of um, KNN, right? So k neighbors classifier. So I will just create an object for that and put at rf classifier. Then I will first I need to fit it. So k KNN. So KNN, and I will do classifier dot fit. This fit function will try to learn from the training data. So I will have vectorized train document as an input and train labels. From train labels and vectorized train document, it will learn the parameters, and after that what I can do is I will predict it. So k prediction, I will do KNN classifier. So now model has been trained, model will be trained, and then I will use KNN classifier to predict for vectorized test documents. Now it will be shown in KN prediction, and then I will call the function called metrics report, where we'll calculate for where we are going to calculate for precision recall F1 score. So in that I will pass the value, first is model name, so I will just pass it KNN, that's the first parameter. Then second parameters will be the test labels, the actual labels, and the predicted variables. So predicted variables is KNN prediction. So if I run this, KNN classifier is not defined. Okay. Okay, so let me check what's the issue here. Again, KNN classifier, key neighbor classifier is there. Then classifier dot fit. I have a train variables and KNN prediction, KNN classifier dot predict vectorized test documents and metric reports is this. Okay, this looks perfectly fine. X has 19 feature and expecting to predict 7 zeros as input. Why it is expecting like that? Okay, again I think I made some mistake. Let me check what is that mistake is. Classifier dot fit is there. I've put the same train documents and train labels and KNN prediction. Okay, so ideally it should work it out. Okay, let me check for the old code that which I have written earlier. So if I okay, let me again write this here. I'll just copy paste. The idea should work it out. Okay, this is done. Okay, this should be done. I haven't. And this now. Okay, again I have made some mistake here where it is not able to predict the test document. Okay, let me show you earlier in this. Till where it I have done this stuff. Preprocessing, TF-IDF. Let me KNN classify. Just a minute, I think it's taking time in this preprocessing step here. Okay, now KNN classifier is running right now. It's predicting the vectorized value. Okay, so I think it may take some time to train and predict this value. So let it take some time. What I will go do is I will go for another classifier by that time. I will explain you quickly because I think we have only 15 minutes left. So I can quickly explain the other things. Then I will show you the code here directly and just tell you how it is running. Okay. Now next question is next is decision tree. Okay, now decision tree classifier is another type of classifier here. So earlier the KNN used the distance kind of like it to identify that a point belong to which of the class based on the distance between the points. This is a different kind in which it is trying to create a tree kind of thing. So for example, in the given image, so the at the leaves we'll get the basic classes. So in this case we have class of whether the person will get a loan or not. So these are the classes. So how it will create a tree for that is it will first check the whether the age is over 30 or not. It will from that it will check other parameters. It will start with one parameter and then it will go for another parameters, that is if age is not 30 then it will check for whether salary is over $2,500 is or not, or if it's age over 30 then the number of children is greater than 2 or less than 2 or not. Okay, and then based on this again for each parameter it is getting get loan or don't get loan. Okay, so in the leaves we will have the actual classes. So for example in our case the 90 classes will be at the leaf and the other features will be taken and over it and try to build it. So what it will do is it will take the data set and will divide the data set into small subsets. From each small subset it will try different permutation combination to identify the which feature suits which better. So based on that it will try to build trees for all those data sets. Now once the multiple trees are be done, it will what it will do is it try to combine those trees and try to see that which type of tree is predicting better. Okay, so that decision rules it, that this classifier trying to build a decision rules on top of that. Okay, so once we have the decision rules about if a document is given, I have 90 labels, so it will try to identify which decision I should take to classify a particular label for the document. So it identify those scenarios and based on that it will classify. So to do this okay, so our KNN classifier is done. So for that we got 33% accuracy, which is quite less. So we will see about that later. Then we will have decision tree classifier. So decision tree classifier, just I said, like it is run here. So let me run it. Let me run there as well in case. Okay, I already have run that earlier. So it got decision tree has pretty good model. It gives an accuracy of 74%, just like that. Okay, so I'm just talking about accuracy now because it gives an overall picture of how the model is. Now the third type of classifier. So for this to write the format will be almost same for all the classifier that I'm writing. So we just have to import a classifier name. You will create an object of that classifier using calling that just like in this case decision tree classifier is there, earlier KNN neighbor classifier is there, just like that. Then from that object you will try to call a function called fit, in which you will pass out vectorized train documents and train labels. Okay, similarly for then once the model has been trained it will try to predict. So to predict you have to use that object name dot predict class and you have to pass the input as vectorized test document. So once you have this then you call the metrics report function, from where it will calculate the all the accuracy recall precision for an actual test label and the predicted test label. So for that we'll do that. Let me see. Okay, so I think I have some problem here if the code is not working because I might have done something wrong in the data preprocessing stage. I will check that and I will update that also later, but I will let me focus on other classifiers as well. So I will share this code as over the, I will just copy paste later in this in that collab that I'm sharing with you. Now, the bagging classifier. Now, this third type of bagging classifier is third type of bagging classifier is called assemble learning method. So what it tells is, uh, it will also what it will do is it try to create some small classifiers. Okay, so it will create multiple independent algorithms. Okay, not small classifier, it will create multiple independent algorithms and will train on different subsets of data. Okay, so based on different subsets of data, and then you will try to combine it. Here you will not use a tree concept. Here you will use directly normal classifier concept, uh, and you might use multiple methods, but for different type of subsets of data. So here you will have m number of classification models from which you will get a certain kind of prediction, and based on that, you what I will try to do is you will try to uh, either take an average of those classification models, or you will take certain voting mechanism to identify the best classification model, and you'll produce that classification model. Now this is a class of bagging is a classifier is a class of different kind of classifier which includes random forest as well, and it makes with the combination of decision trees and all that. Okay, so this classifiers is also is used, and it takes a lot of time to predict, because it is making classification models on when we are seeing subsets of data, it's still a big kind of subsets of data. Okay, so from this multiple subsets of data, it will try to predict it. So once if I run this thing, I got the average value of 74% accuracy. Okay, so 74% accuracy we got for bagging classifier. Now for random forest classifier, just another type of bagging classifier, but here we are using combining the bagging concept plus decision tree concept. So let me show you how it works. So here, okay, now how the data set, how random forest works, it considers one of the best classifiers available in the uh, available in the libraries. So what it do is it will in the same way how decision tree works, it will divide the data sets, and from that data set try to create a decision tree with some different, and that too with different number of features. So it will bring lot of random forest, so it will bring lot of randomness in while choosing those data subsets or the number of features that we are having. So suppose in this case, so it will take for n number 4 different combination of features, it create different decision trees. From the decision tree we are trying to classify different classes. Okay, now once these classes are combined together, they will do a majority voting thing, and from which we will try to find a final class. Okay, so random forest will do for each and every document. So for each and every document it will create multiple decision trees from where it will try to classify that the document should come to which kind of label, assign which kind of labels. So that kind of this thing is there. If you want to know a little bit more about random for is something we should know more about in terms of classifier. So you can see a lot of tutorials out there with the mathematic aspects, which can able to understand that how they are creating multiple decision trees, and how they are randomly selected and different features from where how they are labeling them. So a lot of concepts are there. I'm just giving you overview of that. Now if you run this model also, what I got is 64%, even though it's one of the best but uh, classifier models available in the market, but for this kind of data set it is able to produce only 64% of the accuracy. Now there's something called as boosting concept, boosting classifier. uh, Here we are specifically talking about gradient boosting classifier, so let's talk about that also. Okay, so for gradient boosting classifier, it is also works. It's also one part of bagging. It comes under bagging classifier. The only thing is here the concept of base classifier that we are having, we usually call it weak classifier. So the base classifier that we are having, base classifier 1, 2, and base classifier n, they are weak classifier. When we say weak classifier, that means uh, it performs little better than random guessing. So if you have seen the lectures and all that, you might see that for a particular, like for example, to calculate the ROC curves and all that, you have to keep certain threshold. So in this boosting classifier also, for that algorithm, we have to keep certain threshold. Now the threshold for ROC curve usually say that 0.5. So below 0.5, if you do that, the ROC curve will become bad, the threshold thing. Similarly, the certain threshold will be there. Now when we say weak classifier, it tells that it is still little bit better than random guessing of 0.05, and based on which it try to create a decision tree of small depth. In random forest, we can create decision tree of very high depth. So when we are saying depth, that means here the depth is 3, 0, 1, 2, 3. See, 1, 2, 3. Only 3 layers are there. So in random forest, you might have n number of depths. So for that also, you have to put certain kind of, it has a parameter with respect to a random forest classifier. But in boosting classifier, the depth will be max to max 1 or 2 or max to max 3 depth kind of decision tree will be there. So it will take weak classifiers, and then from this weak classifier, the learning from the weak classifier, it will take combine all those classifiers to make a final classifier, which take the advantage of all those weak classifier to predict the predict to for predicting the sorry, for classifying the multiple labels that we are having. So this is for bagging classifier, boosting classifier. So boosting classifier, for when we run this, we got 74% of accuracy. Okay, now we have two more classifier here. So this one is naive based classifier. Naive based classifier, I don't have image for that, but it works on the concept of probability. So for each, what naive Bayes do is, it will, for each label, it will for given a document, for each label it will provide certain probability. So higher the probability, that means the high chance that the document will be labeled to that, will assign that label. So naive-Bayes classifier will assign the probabilities of that and try to predict. So in this case, the naive-Bayes model has provided us 43% of accuracy. Now support vector machine, in that support vector we calling support vector classifier. In support vector classifier, so the support vector classifier will look something like this. What it will try to do, doing a training, it will try to create a hyperplane, that is you can see in green line. Now from the green line, what it will try to create a hyperplane such that on the opposite sides the different classes should be there. So in this case, the lower triangle, if you see, the stars will be, the hyperplane divided the stars into lower and the red dots into the upper part. Okay, there's something called maximum margin, minimum margin here. So it will try to find the from what aspect of margin we should define our label. So for example, if I have a new unknown variable and I have defined whether it should come in blue star or the red dots, it will use this margin concept to identify, to calculate distance between this stars and the red dots, based on which it will assign that, okay, this, if that particular input is belonging nearer to the red dotted line, it will give it will give the classification of red dot, otherwise it will give the classification of blue stars. Now once we did this also, here we got the SVM for 81% of accuracy. Okay, now once we do all this stuff, what we did is, for all the models, that 7 classifiers, we calculate all the values like precision, recall, F1 score and accuracy. So for micro F1 score, we for these 7 classifiers, we have produced it here, and we can see that out of these 7 classifiers, SVM provide the best F1 score. The more higher F1 score, the more better the model in its prediction. So in this case, 86% F1 score we got. Now when I was talking about accuracy. Accuracy is different from F1 score. Now, so based on the F1, since we got the SVM as F1 score, what we can do, we can create a classification report for that SVM score as well. So for each class of 89 classes that we are having, so for these 89 classes, it is calculating the precision, recall, F1 score, and support. Along with that, it is also calculating the micro and macro average and weighted average for that. Okay, so for this data that of particular for this data of Reuters data set, we are we have tried for 7 classifier, and for 7 classifier we got in which the support vector machine classifier has produced a better result. For that we have produced a classification report. So this is the overview of that. I will provide the rest of the remaining code with properly correcting the bugs I will fill that in this. I'll also share I will upload the video after this session is over. Okay, so what we have discussed today is, to summarize, because we have done a lot of coding and I have done a lot of errors while writing the code also. I will try to apologize for that. I will try not to do it the next time. Okay, so what we have done is, for the first part, we have created a confusion matrix for multi-class classification. Now, in this, we have discussed the 3x3 confusion matrix for iris dataset. So the iris dataset, the 3x3 matrix will look something like this. And from this, for each class, that is Setosa, versicolor, virginica, we try to create its own confusion matrix by calculating in a certain way. So which we have discussed the process of that. The next step what we have done is, we have discussed about the multi-label classifier. We have discussed about the multi-label text classification, in which we discuss about multi-label classification and multi-class classification. And we have tried on Reuters dataset, in which we have talked about multi-label binarizer also. Like if you have multiple labels, then how you can make a matrix of n cross n, where n is the number of labels, from which can able to help the model understand that which label is what. Then we also talk about the pre-processing steps in NLP task, which is a must-have task steps that we have to do. So based on the pre-processing of data set that we have done, we are trained, we have tried the data set on 7 different classifiers. The 7 different classifiers are KNN, decision tree, boosting, bagging, random forest, naive Bayes, and support vector machine. So these 7 classifiers are there. Okay, so we have done that, and not in this the code that I have written, but in the earlier test that I have done, in that I have found that support vector machine provides the better classifier, provides the better classifier for the router data set. This but again you have to understand that if you go venture into more into this multiple classifiers, there are a lot of options are there, and you have, there's no better classifier, we can say. It depends on the kind of data set you are having and the kind of pre-processing you are doing. Okay, so with that I'd stop the session today. So let me see if there's any questions. I will share all those files and YouTube links later, or you can see that, if you can see one of my earlier videos, from there you can see the YouTube channel where I will uploading the content, and I also share this this collab notebook with all of you later. Okay, with proper output, with like that. So yeah, you can see all the videos. So the YouTube link, if you want, just give me a second. I will just give you the YouTube channel link. So there also I will provide the link of this video. I will upload this after this thing is over. Okay, so my email is, I'm just writing it down. This is my institute ID. So this is my email ID. Please copy it down. So yeah, that's it from my side, and since it's already 8, so have a nice weekend ahead, and I'm closing the meeting for everyone. Thank you everyone for coming for this session.